All right. Hi. Good morning, everyone. I'm Johannes, and it's a real pleasure for me that you joined my session, and I'm really happy to be here again. I've been to this conference already last year, and really enjoyed the people, the talks, and also the location. So yeah, really happy to be back at this point. Let me start with my talk with a couple of questions to you. So first of all, who is working in a larger enterprise with several business units, locations, and even regions in the world? Okay, yeah. So who of you is working in this company, and this company was originally doing business in a very different domain beside, let's say, software as a service or cloud, for example, some automotive stuff or retailing or whatever? Okay, also some of you. Are you now working on solutions that combine basically the software as a service business or cloud service business with a more traditional like business like the automotive sector? So for example, some hardware components in the car combined with the backend in the cloud. Okay. And have you ever been part of some transformation journey, let's say from enterprise IT to cloud or from waterfall to agile? Okay, most of you, I assume, right? So I'm not asking you about the success of these transformation journeys. This is a different story, but this talk will focus on basically transformations in cross domain environments. So I'm Johannes. I'm currently working as a system architect for Bosch, mainly in the connected vehicle sector, and had several other positions before. So Bosch is basically a global player in this field, not only in the automotive sector, but heavily represented there worldwide. And the connected mobility sector that I'm also participating in is basically following this vision here. So traditionally in the automotive sector, what you see today, it's heavily centered around the vehicle itself. This will change very much in the future, or is already changing a lot. So it will be about intermodal transportation services and connected mobility and so on. So when building such systems and providing solutions to our customers, you see basically in the last, when you overlook the last couple of years, several things have changed. For example, when you think about the usage of IT infrastructure, so in a more enterprise environment, you were heavily using servers, provisioning servers, and so on. This changed a lot with different cloud platforms available until now, what we have seen in the recent years with serverless technologies and so on, but also the whole application development. So how you utilize this infrastructure in order to develop new applications has changed a lot in the last couple of years. And not only the individual parts, speaking about infrastructure and application development, but also the orchestration part. Let's say you want to orchestrate different application components or microservices to larger systems and provide service-oriented solutions to the customer. So when we have a look, for example, at very specifically at the cloud and on-demand journey, it all started years ago already with providing basic infrastructure offerings like virtual servers, storage, and network capabilities. And this evolved a lot towards more powerful abstractions and also more developer-friendly abstractions, to put it this way. So you have today managed execution environments in various flavors. You have function as a service, container as a service platforms. You have also, in terms of communication and storage offerings, a huge variety of services available that you can use to build up your applications upon. So things have changed a lot in the last couple of years, and the underlying trend here is that IT infrastructure and platforms are becoming more and more commodity and standard. For example, when you think about container orchestration these days, Kubernetes is basically the de facto standard in most environments, and if you want to deploy your containers, orchestrate them in some kind of cloud environment, you most probably go with Kubernetes, either with a managed Kubernetes service on some of the big cloud providers, or you can also do it on premise, of course, if there is a need for it. So the essence here is basically that infrastructure and servers mostly become invisible. And this is exactly, in my opinion, the essence of serverless. So serverless is not equal, in my opinion, to function as a service and backend as a service only, but it's everything that helps you to abstract from the actual infrastructure and the servers underneath, so to improve developer experience. I think this is the core idea of the whole thing. And this again helps the DevOps teams, the development and operators and so on. They work tightly together to focus on the delivery of business value. Most probably, you have a better developer experience in most cases, let's say. There are exceptions always, with especially when new things are kicking in, like these function as a service offerings. In the beginning, it was, for example, very hard to debug applications that were spread across multiple functions and so on. So this is still somewhat of a challenge, not such a good tooling support as you would go, for example, with a more traditional application development approach, but I think we are getting there. When we talk about abstractions, we also have to keep in mind that abstractions definitely provide value, because I think most people are here sitting in the room don't write directly assembly code these days, but so you have some benefit here, but you have to be aware of failure scenarios. For example, failure cannot abstract it away. So if there is a failure somewhere in the infrastructure, most probably your application will be also affected. It doesn't matter how many abstraction layers you have underneath. And there's an excellent article from Gregor Hoppe I just pointed here. You can have a look later on. I think it's a very good, he makes a very good point that basically failure doesn't respect abstraction in that sense. So talking about serverless, yeah, you could argue like, okay, we have less servers, we have less of the infrastructure efforts, we have less of the infrastructure to consider. So do we have less challenges in the end? And I would say if you don't start with a greenfield approach, and this was at least true for us, I mean, several organizational and also technical challenges you have to tackle. So here's just a list of examples. For example, if you are an organization with a longer history in a non-software as a service business, you first of all have to learn a lot of things essentially to get to the point until you can really deliver value in the software as a service world, let's say. Also in terms of technical concerns, like when you have started with a very traditional IT infrastructure management and now go for more cloud-centric, cloud-native and serverless approaches in terms of platforms and infrastructure you are using, you have to relearn and maybe unlearn some things that have emerged in your company, for example, in the last decades. And also organizational-wise, of course. So especially in larger enterprises, you typically have silos between, for example, the engineering, development, operations, quality, and so on. And it's something very hard sometimes to get started here, really starting from an existing environment. So I would like to share with you a few of our insights, our principles, our practices that we learned along the way of our connected vehicle journey. So first of all, to give you a little bit of context. So we are in this field of providing a connected vehicle software as a service solution, but also including hardware components. That means we have the vehicle, we provide hardware components like retrofit, for example, devices that you can plug into your car, into the OBD port, for example. And then we have some infrastructure in between and provide to the user, for example, to the driver of the car or to the owner of a complete fleet. For example, companies have typically whole fleets of vehicles. They want to have some interface, for example, to get different use cases consumed, like driver's logbook, vehicle health, driving score, and so on. So there are a couple of use cases we deliver through that system. And years ago, this all started with a very, let's say, traditional infrastructure approach, very monolithic, based on a portal solution that was running in the enterprise IT directly, so no cloud technology involved. And there were several issues, obviously. So first of all, performance and scaling became a problem once we got more and more cars and more customers acquired to the system, and also in terms of changes, bringing changes into the system, because it was monolithic. It was basically grown historically, and at some point in time, it was nearly impossible to change something or to add new features without degrading performance. Yeah. There were a couple of other difficulties, for example, getting the UI mobile ready. This was not a big issue in the beginning, because when we started years ago, this was still not the hot topic, but these days it's definitely important. So what we got basically is rebuilding the whole system and also rethinking the technology and architecture choices we made in the beginning. So infrastructure-wise, we were mostly doing this in a serverless way. So we didn't really use any virtual machines or anything that we need to manage infrastructure underneath, because we really wanted to focus on the delivery of business value and not on the management of infrastructure. Architecture-wise, we chose to mostly base our services on 12-factor apps, which are implemented as cloud-native microservices. And the whole process to deliver this system should be strongly based on continuous integration and delivery, and also making it possible to not only provide a responsive web application, but also the capabilities of the system exposed to the customers using RESTful APIs and messaging technology. To give you a rough sketch of the overall architecture, so we had the device services, which was basically split into a device connectivity and device operation. So you can imagine, if you have devices in the field built into the vehicles, you have to update them over the air. You have to ensure that they are correctly working and connected to the backend. This is all meant by the device operations layer. Then we had different devices here, very simplified view. A basic device which was more targeting the low-cost sector, so which was very cheap, also as a retrofit solution. But feature-wise and quality-wise, also data quality-wise, wasn't as good, but was good enough for the basic use cases. And then we also had a premium device, of course, for the more sophisticated use cases. And as you already see, the devices itself is not a black box. So the device itself has its own architecture on the device. So there were different layers. Without going into too much details here. Then we had, on top of the device services itself, a couple of base services, like a shadow vehicle, where we basically track the last state of the vehicle itself. For example, the current mileage or the last position, and so on. So having a digital twin, basically representing the vehicle. And then on top of that, some more specific use case services. And these are really the services that provide the visible value to the customer. The front end was delivered as a single page application and connected to the underlying services using an API gateway. Then we had several other components and services available for the end-to-end integration and testing, for example, device simulators and load generators, because this is essential when you have a system like this and really want to scale it. You have to do load testing at regular time intervals, and you also, in terms of doing the continuous integration and delivery in an effective manner, you need some simulated devices, because you cannot always do drives in the wild for testing. Deployment-wise, we had a multi-cloud setup, so parts of the system were deployed to AWS cloud, and other parts were deployed to a private cloud, Bosch IoT Cloud, which is basically Cloud Foundry environment that is hosted Bosch internally. So just to give you a bit of context, as I mentioned already, for us it was not a greenfield approach. So we were starting from this old system, and we really had to rebuild the system with in mind. So, for example, also migrating the existing customer. So we had to have a migration path in mind. So we also tried to take as much as possible of the existing organization with us, because there was already a lot of expertise in the organization, like dealing with the devices, connecting the devices to the backend, and so on. This was all pretty valuable and could be reused. So, organization-wise, it was quite complex because we had a highly distributed environment when we started. So, teams, around 10 agile teams. Distributed across different locations and also distributed across different legal entities, because Bosch is a global company and not everyone is part of the same legal entity, and this makes some things really hard, right? when you start off with that. And from there, we really started the whole journey towards the new setup that I just pointed out. And the other thing was not only the organizational setup, but also the structures behind and the mindset. So we had, of course, the grown organizational structures over the years, and we had established key positions that were basically taken over in many cases. And here you also have to discuss, always have to discuss with different stakeholders why you would now like to do things differently, very differently, like not only changing a library but radically differently, like not building on the enterprise IT anymore, but going for a public cloud, for example. This is really a big move for such a company. And one example is like the topic IT service management. So IT service management, some companies, they had it already in the past, also before the cloud age, so to speak, but they were doing it in a very different manner. And I'm really convinced that you still need it, IT service management. You need to manage your services in order to deal with incidents and so on, but this must be really driven by modern engineering principles like continuous delivery. So I will come back to this point later. So the first point I want to make in this context is try to not split the two worlds, but play well together. What do I mean with that? So typically in an enterprise, you have the enterprise IT, which is very long living, and you have that already for a couple of years or even decades, right? You typically have a layer silo, so that means you have teams that only manage a certain layer of the whole system or a specific database and so on. So, and you have sophisticated firewalling, you have limited scaling capabilities, of course, because many things are, or basically everything is on premise, so it takes time until you get a new server installed and so on. On the other hand, many companies already started years ago to experimenting with cloud environments, both private, hybrid, and public cloud. Also we did. And there you very quickly get a split. So you have basically the old world, the enterprise IT, and then you have the new world, the cloud environments. And most of the time you have multiple of those. So you have a decoupled organization and also decoupled infrastructure in terms of billing systems, master data systems, and so on. And sometimes it's also very technically and organizational very hard to bridge these two. So there are some discussions going on. Does it really make sense to bring them together, or should we just split it? Maybe you know the discussion about bimodal IT or two-speed IT. In my opinion and in our experience, it doesn't work in the long run. You can start with that. You can, for example, say in order to make fast progress in rebuilding a cloud-native system or a serverless system, in order to proceed faster, you start off with a separate island solution, let's say. But in the long run, you have to have a plan and a roadmap how you bring the two worlds together, technically and organizationally. The second point is do your homework. So this, what I mean by this is like it's not really about just starting with a new technology, starting with a new platform, but the underlying organizational structures, the mindset, the organizational transformations that are required need to be carried out in parallel at least. And I think one of the most important points here is moving from these more enterprise-ish silos that you traditionally see in companies to software ownership by empowered teams. So I don't mean these silos negatively, because I think the companies in the past, they had a good reason why they had these silos. For example, if you are in the hardware delivery business, there may be a good reason for this. Yeah, you have a separate quality department, a separate test department, and so on. There may be good reasons, but if you are going to the software as a service business or cloud service business, things are different. And I think one major driver must be software ownership. What do I mean by software ownership? So one strong advocate of software ownership is Charity, and I really like her tweets, and this is just one of them. So what she is pointing out here, you don't have software ownership if you don't have the ability to watch your code run in production. And here is the comparison. That would be like not letting a chef test their food, making an artist paint blindfolded, printing the handwritten first draft of a novel with no editing. So when you think about it, it really makes sense, right? Because if you don't get this end-to-end delivery and end-to-end responsibility inside the teams, then you can't deliver fast and you can't deliver value as quickly as possible, which is essential nowadays. So talking about these essential changes that are required in both in organizational structure and also in mindset, there are a number of points you have to consider. First of all, you need people that relentlessly explain what's going on in the new world, also to the management, right? I mean, the bottom-up approach is fine. You can start with it, but at some point in time, you need to have management buy-in also from the higher level and top management. For example, explaining them that speed, quality, and cost reduction is not really something either or, but you can achieve basically everything because if you take the holistic approach, if you get to the point that you get a continuous delivery principles implemented and planted into your organization, both organizationally and technically. The next thing is it's not always only about facts, as you all may know. So, for example, people and politics play a key role when you think about people need to acquire new skills. Think about a traditional QA department. They have to deeply understand how continuous delivery is working and what they can contribute to that and how they can actually help to automate most of the quality checks and so on. So this is, for example, a huge barrier, bringing this to people that are not natively familiar with this concept. I think in the development community is everything pretty clear for years already, but there are people in companies who may have heard the term already, but do not deeply understand it. This we have to change. Also, you have a need for less people in certain departments. When you put the quality things inside the teams with end-to-end ownership, then of course you need less people in central departments like a central QA departments, and this again has implications because department leads in the central departments will lose headcounts. Yeah? So this is also a very important aspect you have to consider here. Talking about processes and roles, I'm pretty sure that most of you will say, okay, do we really need processes, formal processes, and so on? We are agile, we are just adapting as we are going. And this is definitely true. We have to do this. We have to continuously inspect and adapt. But at some point, at some scale, I'm convinced, and this is also what we learned, you need to have some processes. And you always have to ask yourself, are these processes still appropriate? Do they help us? Do they support us, or do they hinder us? And I think this is also a continuous process, adapting the processes itself. But if you have like a setup with 8 or 12 Scrum teams that work together on a system or a solution that you would like to give to your customer, you have to at least think about what could be an appropriate process and what could be appropriate roles here. Yeah. Finally, stay open for continuous change. So everything changes, not only the technical stuff, but also the organizational things and the aspects how your organization is structured, and also the processes and roles. To make two examples here, of course, sometimes you need some temporary setups or some temporary enablers, like, for example, this idea of having a DevOps evangelist team, can be very beneficial to bring the DevOps mindset and continuous delivery inside the organizations, for example, to teams that were not practicing it before. But you have to really be careful that these enablers or these intermediate solutions are not becoming permanent, right? You always have to keep in mind what is your target picture, what you want to get in the end, and then using these enablers to get there. Another example would be trying not to split DevOps from service management. So DevOps, basically the end-to-end delivery responsibility inside the teams, they should also consider service management aspects like incident management and so on. Third point is try to keep the things that already work, right? So if you do something new, like okay, you decide you rebuild an entire system based on serverless principles and serverless technologies, there may be a temptation to say, okay, we are doing everything new now, and let's just drop all the processes we had before because it's obsolete now. But I think this isn't true, and this is also something we learned, because there are things that are still valuable, like incident change management sounds a bit old-fashioned, but if you apply it the right way, for example, driven by continuous delivery principles, this can be really beneficial. And if you have already some prior work and expertise in your organization, this can be really beneficial to get to a productive service offering. Also about system architecture. Architecture is an interesting topic, because architecture in the past was something completely different as architecture is today, especially where you have empowered teams, and many of the architecture work is also happening inside the teams. So there's always the question, do we need some overarching system architecture at all, or can we just drop it? And what we learned, you also need it in the new world, but you have to define what is basically the responsibility of the system architects and what is the responsibility of the teams. And this is something you have to define for your own organization. But you need some technical alignment also in terms of interface and format definitions. If you have a couple of services deployed or serverless functions deployed, you need to define the interfaces properly. The next point is nice to have in the past, essential in the future. So there are some aspects which were already beneficial if you had them in the past, but from our experience in the future, this will be absolutely essential. So there will be no discussion whether we need this or not, but this is just something you have to have, otherwise there's no way around it. Some examples: high degree of automation in terms of test automation, security checks, compliance checks, and so on. In order to scale common API guidelines across teams, which is best organized, for example, as an API guild who also has a governance function, building these guidelines, doing review of the APIs and so on. Strict API evolution, so not breaking change into production instantly, but having a process how you can introduce breaking changes, having the consumers notified in advance and so on. And from our perspective, this is not just a technical detail, all these topics, because in the end, if you want to scale and if you want to reduce costs and lower effort in the development, you have to adapt these things. Next point is seeing continuous delivery as, I would say, the business critical driver to scale. And with scaling here, I mean several aspects. First of all, scaling the solutions itself that you are building, but also scaling the organization. If you think about, you have a highly distributed environment with several teams, and the teams should work independently on the different parts, like the different microservices that contribute to the overall solutions. you need to have processes in place that ensure that each team can deliver independently, so that you don't have an overall orchestrator that is basically a bottleneck in the end. And scaling also not only technically but also economically. That means that your solution can basically scale and that you can really earn money with a solution that you build in the long run. And for this, there must be deep investments into automation. Automation is basically the enabler to trust the underlying delivery pipelines. So if you put a lot of stuff into the delivery pipelines, like quality checks, compliance checks, and so on, and you replace the manual tasks that have been carried out before, you have to have a proper implementation of those automated processes that you can really trust in them. So invest in automation and build the delivery pipelines, and each and every change has to pass the pipeline, even the smallest config change. What we come next is, like, when you build up these systems, you build your organization strongly on continuous delivery principles, you also have to treat your whole continuous delivery machinery and the whole infrastructure underneath as business critical system. This is also something you have to explain to certain people in your organization, because in the beginning this was just like it was development tooling, let's say. But at some point in time, if you really depend on the continuous delivery pipeline to push every change into production, this is becoming business critical, because you can't deploy, you can't update anything without the pipeline and without the CD infrastructure running. So just to think about, for example, we said you want to reduce the silos. This is also what we did, and then you don't have separate test and QA teams, because a lot of things are automated and now in the responsibility of the teams that also build the pipelines. This is also something you have to consider when you go this way. It's essential to have all these aspects implemented in the delivery pipelines. And also about freezing. So freezing and staging, for example, freezing an environment for a couple of days or even weeks, doing sophisticated staging concepts many people did it in the past, and maybe it made sense for some environments. But if you have a highly distributed environment with serverless functions, microservices distributed across different clouds, for example, in a multi-cloud setup, this doesn't really work, as you can imagine, right? You cannot freeze the whole system for a couple of days or weeks. And when you think about it, it doesn't really make sense, because the underlying layers, like you have abstraction layers from the cloud providers, you can't freeze them either. So if you don't build upon servers directly and you have some platform, for example, some serverless platform that you use, or some container orchestration platform, you can't freeze this either. Talking about base services, here you really have to be careful not to overload the development teams and the agile teams that want to deliver business value. So if you have teams that are working on microservices that really implement the use cases that your customers need, they have to use, or they typically use, a number of base services in order to implement their services. For example, database offerings and for example, we have data analytics big data based on a Hadoop stack in our architecture for doing predictive diagnostics, for example. So the algorithms are analyzing in the background the data from the vehicles, and this is something we decided to cut out. So the team that is developing the algorithms and providing the service for predictive diagnostics of a car does not really operate the underlying Hadoop infrastructure. This is basically cut out to a separate team which really takes care about the underlying Hadoop infrastructure. And this really helps teams to speed up on the delivery of business value. So let's now, for 2 slides, enter the world of devices. So we have talked a lot about cloud serverless environments. More like the devices and hardware world looks a bit different, because you usually have a number of restrictions in terms of the hardware capability. So you have limited resources on the hardware. Your architecture may look very differently to what you build in the backend, for example. Also, you have different platforms and tools, and it's not always really about one device directly connected to the backend, but in the automotive sector, it's often a chain of devices. So you have a connectivity device in the car that's connected to multiple sensors, and these sensors are again connected to vehicle components. So you have a whole network of devices in the car, and the connectivity unit is basically just the gateway to the backend. But in terms of the data models and the APIs, it's sometimes important also to consider the underlying device infrastructure in the car. And also regarding safety, if you have devices that could potentially control your braking system while you are driving, this is something completely different than just updating a microservice that does some user profile management on the backend side. So there are different considerations when you enter this world. Also, when you want to offer entire solutions, so not only the software as a service backend, but also let's say the devices itself, you want to sell the overall solutions, then you have to think about the life cycle, right? How gets the devices mounted into the vehicles? How get they replaced if they are broken and so on? And this is a whole new world of logistics and legal questions you have to consider if you want to deliver such a solution. In terms of organizational structure, there are also interesting questions arising. For example, do you really cut feature teams? So a feature team would have parts in the UI, parts in the backend, and parts on the device, right, end to end, if you really think consequently. What we decided, we cut, for example, at the device side, because it was a very different world, at least when we started, and we are still going for the setup. Tools are completely different. Developers are in a completely different world. Maybe we change this in the future, but we really went here with clear interface definitions. This is somehow a big issue because it takes time to align on the interfaces. We know that, but this was basically the trade-off that we decided in the first place. So it really doesn't matter how you do it. The important thing is here that even if there are if things are different in the world of devices, you also have to do the automation on that side. I mean, not only build automation, but also test automation. For example, providing device simulators or API controllable devices to the backend teams, so that they can really do the continuous delivery pipelines and test their code against devices automatically. So devices are no excuse, even though they are different, are no excuse to skip test automation. The 8th point is design for end-to-end system observability, and with this I mean really to be able to track, for example, an event or a message that was flowing in from the car through the backend and delivered to the user, for example, using a UI or an API. Depending on what interface of the system he or she was using. Last point is distinguish your non-functional requirements by system interfaces. This is also something we learned. Our system had two major interfaces. So one was, if you look at the backend system, one was towards the device side, and the other one was towards the front end, towards the user side. And typically you have very different non-functional requirements. For the user, the UI, for example, should be always available. Our devices could buffer some events and messages for some time at least. That means essentially if the system will be down towards the device side, let's say, it's not really critical as long as you don't have use cases like accident notification. Then it's a different story, but for monitoring vehicle health and having a driver logbook, if your system is down towards the device side for a couple of minutes, the device can buffer these messages and send it out later. Okay, so we have seen some points, what we learned, what our insights was, and I also want to share some of the bad practices that happened For example, sales-driven architecture. So what do I mean by that? Sales-driven architecture is that when in talks with customers, technical experts are not directly involved. Then you get something like SLAs confirmed that cannot really technically delivered, or it's too much expensive to deliver them. Just to make an example. Also talking about the option of selling an on-premise variant of a software as a service offering. So you started with the development of a software as a service product, and now you go out and say, okay, we could also sell this on-premise as a product, basically, software as a product, basically. But this is a completely different model. So your DevOps teams, they are not really prepared for that. They are really focusing on delivering a service versus delivering a product, a software product with installation guidelines, and the whole operations model is a completely different world. Also, what you should be very careful about, if you provide a software as a service to many customers, then you should never allow a customer a deployment veto, for example. If you only build the system for a very large customer and it's only for this only customer, then you can do it, of course. Then it's more like a partnership, a collaboration between your company and your customer. But if this should really scale to many customers, this is an absolute no-go. And last but not least, the point of politics-driven architecture. So in many companies, you have platform initiatives going on underneath. So they try to build platform components that should be reused across business units and so on, which makes sense in the first place. But you really have to be careful that the platform development is not isolated from, let's say, delivering the solutions that are really going out to the customers. Right, the platform must be really tightly coupled and tightly synchronized with the efforts that are going on in the teams that deliver services to customers. Then, last but not least, very quick, 3 more helpers that we think were valuable for us. First, technology radars on team level, but also on business unit level, that you can, for example, prioritize which technologies make sense to use and which technologies you can have a deeper look in order to improve certain things in your teams. Having code project blueprints and templates, and this you can nicely do in an internal or real open source manner. So sharing this, so teams don't have to start from scratch when building pipelines, functions, microservices, and so on. And also having enough documentation and automation for seamless onboarding for new team members. So, yeah, that's it from my side. Just to summarize the points. Play well together. Don't split the two worlds, enterprise, IT, cloud. Have the change. Do the change in mindset and structure. Keep the right things that you already have. Don't drop everything, because some things are valuable, some things are already essential. So you have them probably already. Automation, for example, high degree of automation, but will be essential in the future. And continuous delivery as really the business critical driver to scale. Thank you very much. If you have questions here.
Hi, thanks for an interesting talk. So you mentioned about public cloud versus Cloud Foundry. I'm just wondering what factors do you have in place, or what rules do you have in place about when to use public cloud versus your own internal hosted Cloud Foundry solution?
Yeah, that's an interesting discussion. I mean, there are different points of view. One could be that you as a company, this was at least the strategy in the beginning, you want to put, let's say, specific data inside the company. You don't want to put them on the external cloud. So these applications where you consider the data very valuable, whatever that means, yeah, it's really hard to determine. These applications and data structures would be deployed internally. Another thing would be, for example, when we started with Cloud Foundry, yeah, it was still pretty new. So there was the hope that Cloud Foundry was be adopted by more cloud providers, which was not the case, right? It's now going towards Kubernetes and other abstraction layers, let's say. Yeah, so we have to see in future how really the split can be made. Yeah. It's more historically grown. Yeah.
Hi. Regarding the continuous delivery topic, so my question would be, I mean, it's, let's say, fairly easy to build pipelines and to work with new code bases, but what do you do if you have inherited a huge legacy code base with little to no tests and so on? How do you get from this state to continuous delivery, like along with splitting microservices? Do you like dedicate 3 months of writing unit and integration tests and so on, or you have some other suggestion?
Yeah, so we followed the approach of really rebuilding the system step by step. So we were also reusing some of the components of the old system, like the connection server, that is basically the connection point between the devices in the vehicles and the backend, right? We were replacing this step by step, but we didn't really take the old code base and try to make it continuous delivery ready. So to be honest, I'm not sure if this makes sense in many cases, because it can be really expensive, and if you can basically cut out function by function or feature by feature from the monolithic code base and rebuild this part as a serverless function or as a microservice and deploy it somewhere and have the continuous delivery pipeline running from the start, including test automation and so on. So this is at least the approach we followed.
Hey, that's really insightful talk. Thanks for that. I have a question on customers blocking deployment. Could you elaborate a bit more? What exactly can it block, or maybe it blocked for you, and whether it's like part of the customer promise that you have for the customers that they can block deployment?
Yeah, so you are probably talking about the deployment veto, right?
Yeah, sorry, yes, deployment veto.
Yeah, so if you have this in the contract, for example, with the customer, so we are doing a lot of B2B business, so you have special contracts and negotiations with other business partners, and if you get something into the contract that goes into that direction, for example, you want to roll out a change, and the customer says, no, I don't want to have this change, right? This could be on a different level, right? If you are implementing this using feature toggles and so on, this is a different story. Then you are in full control and you have multi-tenancy implemented into the system. You can disable, for example, certain features or certain functionality for specific tenants, which is then the same to the customer. But you should never allow the customer to control the internal deployment chain or the internal deployment process, meaning that you cannot deploy a new version of the software, right? This should be completely transparent to the outside world. It should be only about interfaces, that these interfaces are stable, and this is the only thing that you can negotiate or put into contracts. Yeah.
Thank you.
Any more questions? Thank you very much.